Okay, we're going to continue the lesson today, how we factor algebraic expressions completely, including trinomials with lead coefficient of 1. So our first question is, how do we factor polynomials using the greatest common factor? So we're going to use a lot of yesterday's lesson in order to do that. Okay, so today we're going to rewrite the expressions in factored form. Factored form is the inverse, factoring is the inverse of multiplication. So instead of multiplying two numbers to get the product, we're going to take a number and rewrite it as two different factors. Okay, factored form means written as two or more factors. So if I take a binomial like this, I can pull the 12 out because 12 is common to both of them, and I want to rewrite them as two factors being multiplied. So here in the second example, 12 and x plus y are both factors. Okay, to factor a polynomial means to express a polynomial as the product of the greatest common factor between terms and the polynomial of factored terms. Okay, so if we look back here, when we say factor this binomial, okay, so in general, this is how to factor a polynomial. We find the GCF between 12x and 12y, and we pull that out. And then we rewrite the terms inside having factored the 12 out. Okay, so it's x plus y if we had gotten rid of the 12 on them. Okay, so here are our steps. We're going to determine the GCF between all terms in the polynomial. Then we're going to write the GCF on the outside of the parentheses and rewrite all terms by dividing the terms by the GCF. And then we're going to check our problem mentally using distribution. Okay, so the GCF between bx and by is b. Okay, now I want to think in my head, bx, I want to take each term and divide it by the GCF. That's going to be x, so I'm going to rewrite that as x. Okay, and then I'm going to take by, the second term in this binomial, I'm going to divide it by b, and I'm left with y. I have that plus because that was brought over from there. Okay, so essentially what we're doing is we're rewriting the problem so that you would require distribution in order to get it back into the form that you were given it in. So if I were to distribute this, that would be bx plus by. So that's what I mean by checking it mentally. So the answer to this question is just b times x plus y. That is the answer. That is the polynomial in factored form. Okay, so let's go on to the next one. We're going to think about the GCF between 4 and 8. The GCF is 4, so I'm going to pull that out. Notice that this has x, this has y, so there's no GCF. The variable terms have nothing in common. So I want to think of this as being divided by 4 and this as being divided by 4. So I have x there and 2y remaining. So let's use distribution in our head to figure out, to make sure that this is the same as it was previously. 4 times x would be 4x, and 4 times 2y would be 8y. Okay, so that is the answer there. Okay, so this is the answer for number 2. For number 3, if I were to write it in factored form, I would think about the GCF between 12 and 18, which is 6. And again, I have x minus y here because, oh, no, that's not true. Okay, let's see. I want to think about 12x divided by 6. That's going to get me 2x, so that's what should be in here. Plus, now what would I need to multiply 6 by in order to get to 18y? Well, that would have to be minus, actually. I'd have to multiply, so if I divide this by 6, I'd have 3y. Okay, so let me just mentally check it. 6 times 2x is 12x. Minus is there, okay, and 6 times 3y is 18y. All right, so that is the answer. The factored form of 12x minus 18y is 6 times the quantity 2x minus 3y. Okay, so again, I want to think about the GCF between 6 and 18, which is 6. Okay, now a very common mistake that people make is they think, oh, well, I take the 6 away, so there's nothing left. And then they forget to write that really what's left is 1, because remember, you are thinking about taking the terms that you used to have, you're taking the terms that you used to have here and dividing it by whatever you're pulling out. So 6 divided by 6 is 1. And keep the minus. 18c divided by 6 is 3c. So if we look at how this would distribute through, okay, so 6 times 1 is 6 minus 6 times 3c would be 18c, and we would get back what we had before. So this is the factored form of 6 minus 18c. Okay, again, a common mistake is to not write the 1 there. People will say, oh, if I take 6 away, I don't have anything remaining, so they'll put negative 3c there, but they'll forget that there's a 1 that you get when you divide 6 by 6. Okay, so remember, pi is just a number. Pi is standing in for an irrational number. So that is a common factor between those two. If I take pi r and divide it by, I want to divide it by pi actually, because that's what I'm factoring out. I'd have r remaining, and if I divide 2 pi h by pi, I'd have 2h remaining. Okay, so if I factor pi out, which is the greatest common factor between pi r and 2 pi h, I would have r minus 2h left, because if I multiplied these back again, that would be pi r minus 2h times pi, but then I could reorganize that to be 2 pi h. Okay, so the factored form of number 5 is pi times r minus 2h, or pi times the quantity r minus 2h. Okay, now the GCF between these three terms, so the coefficient of the first two terms is 1, so the coefficient of the GCF is just 1. Now the greatest common factor between the three terms d to the fourth, d to the third, and d squared is going to be d squared. Okay, because all of these terms share a d squared factor in them. Okay, so if I factor d squared out of the following terms, so just think about them. Remember, what you're doing here is you're just thinking about them dividing by d squared, each of them dividing by d squared. So d to the fourth divided by d squared is d squared. Keep that addition between. D to the third divided by d squared is d. Keep the addition again. And 2d squared divided by d squared is just 2. Okay, so this is the factored form of that trinomial. I factored out the greatest common factor, which is d squared, and I rewrote the trinomial with the remaining terms after I factored. Factoring is the same as dividing out. So if I say I'm factoring out d squared, I'm dividing each term in this trinomial by d squared. Okay, so let's focus on the coefficients for the trinomial number 7. So the coefficients are 9, 6, and 3. The GCF between 9, 6, and 3 is 3. Okay, now 9 has an A and a B, 6 has a B, and 3 has an A. So A is common to 9 and 3, and B is common to 9 and 6. But A and B are not common to all of them. Okay, the factor that you want to pull out has to be common to all three terms. So because A and B are not common to all three, I'm not going to pull out either A or B. All right, so I have 3AB left, minus 2B, and minus A. Okay, and if I check this, I can sort of check it by multiplying it, distributing the 3. 3 times 3AB is 9AB, minus 3 times 2B is 6B, and 3 times A is 3A. So I would get that back. Okay, that's always the sign of a properly factored polynomial, is that when you distribute the GCF through, that you get what you originally had back. Also notice that between the three terms that are remaining inside the trinomial, none of them share a factor. That means that you pulled out the correct greatest common factor. If you had forgotten to pull out some number, let's say the 3A had a B on it, and so B would be common to all three of them, and let's say you didn't pull out that B, it would have showed up inside all three of those factors. So you would have seen that b was there, which means that there's another factor you could pull out. In this case, you could have rewritten it as this. Notice I was just changing the problem a little bit by adding a b in there, just to create another situation. Okay, I think that's the end of the notes here.